Good afternoon, ladies and gentlemen. My name is Filip Granek, and I'm the co-founder and co-inventor of the XTPL technology. And together with Sebastian, we will tell you how the XTPL technology can improve the performance of solar cells in displays. And the global manufacturers of solar cells and displays are seeking ways to make the product more energy efficient, cheaper, and mechanically flexible. One of the challenges that they are all facing is the challenges related to the transparent electrode. Today, as a standard, they use indium tin oxide. This is a material that unfortunately has limited optical transparency, limited electrical resistance. It is not mechanically flexible, and it uses expensive materials such as indium. The transparent electrodes are present both in solar cells and displays. Let us think about solar cell and display as a kind of a sandwich of many layers. Each layer has a different purpose to serve. The purpose of the transparent electrode, shown in the light color here on the screen, is on one hand, in the case of displays, is to drive electrical current into the pixel, so that the pixel can emit light, and the light has to go out to hit our eyes. In the case of the solar cells, the transparent electrode role is to drive the current, in the case of the solar cell, the role of the transparent electrode is to allow as much sunlight to get into the solar cell, so that the solar cell can produce a lot of electricity, and this electricity has to go out with minimum energy losses. Today, as I said, people use indium tin oxide as this transparent layer, as a kind of a surface that is being deposited on solar cell or on a display. At the same time, indium tin oxide, the current standard, has limited transparency and electrical resistance. And this limits the further development of the technology for these two types of devices. So if we could, for example, get rid of the limitations of indium tin oxide and replace it with a fine mesh or fine grid of very tiny wires that are practically invisible to human eye and invisible to the light, then we could get a concept that's shown here on the right side of the screen, the concept of a metal mesh. The only question is if you can find a method to produce these tiny wires in a cost-effective way, because solar cells and displays, these are devices that cannot become more expensive, they need to become cheaper. And in our garage laboratory in Wrocław, this is a western southern part of Poland, we actually developed a method where we can produce extremely narrow lines. On the microscopy picture here you see a line, a silver line, that has a width of less than half of a micrometer. To put that in perspective, this is actually 100 times less than the width of the human hair. And what we find fascinating about this is that we created in, like I said, garage environment, not in a clean room facilities, using extremely expensive equipment. So we think this actually can be a technological breakthrough that may have an impact on global industries. The lines are not only very narrow, but they also have to be electrically conductive. This is just a graph that shows you that we've done a lot of work, we have some statistics. Some of our results are already exceeding the current standards, much better conductivities are obtained. Of course, we do need to work on the reproducibility on our results. And our main challenge now is to get out of the laboratory of making very small samples to make bigger surfaces in a fast and reproducible way. Our technology is being protected by patent application that we have developed in close collaboration with London-based patent attorneys who are actually very experienced in our field of innovation. The technology is based on two main pillars. One is the formulation of the nano ink that we print. You can think of it as a kind of a paint that we use to paint our lines. On the other hand, we combine it with a unique printing method. And having both the ink and the printing method that we developed allows extremely high resolution of printing using what we think is low cost, easy to scale, and affordable method. Our company and technology is being developed by a team that has a good mixture of experience in technology, science, and business. Myself and Zbyszek Rozynek, we are both scientists with over 15 years of R&D experience. We both spent 10 years of our research career working internationally in renowned research institutions. I myself been involved in working with photovoltaic industries for many years, with the global players. I know how they operate, I understand their needs. So the scientific part of our team is well balanced with an experienced CEO, Sebastian, who has been successfully developing businesses for the last 15 years. And Sebastian will tell you more about the market opportunity and our business model.
Thank you, Philip, for introducing me. Thank you very much. Before I skip to the market, I just to spend just a while and go back to the sandwich, because Philip was talking about sandwich and the solar panels and displays. They are very similar to sandwiches. So they always have different layers, and one of them is always the conductive one. And this is our product. And our market is called transparent conductive films market. It was worth $2 billion 3 years ago. It's growing rapidly, up to almost $6 billion in 2020. We know it. And our competitors as well. So, because we have competition, they are working really hard in Germany, United States, Israel, and Canada to replace the current standard, which is ITO, which has problems with transparency, which has problem with resistance, and with flexibility. And of course, there are three features which are the most important on this market. So flexibility, transparency, and once again, transparency. So, as you can see on the slide here, our technology is the best compared to our competitors, but we have to admit we are on the laboratory scale. When we sat in our laboratory, Eureka, then we decided to send results of our research to our potential clients. And they liked what they've seen, and they sent us letters of intent. So we got letters of intent from DuPont, one of the biggest tech company, from Fraunhofer, the biggest photovoltaics institute, from Trina Solar, the biggest solar panel producer in the world, from China. A 5% license fee. This is how we're gonna earn money. So we charge our clients for every layer, conductive layer they produce. They will produce using our technology. It means revenue, $1 million revenue in 2018, $6 2 years later, $6 million 2 years later, and $15 million 2022. Shortly, our financial history. So we gathered in 14 months 11.5 million Polish zlotys, which is about $3 million. And we got it from private investors, business angel, seed fund, and Polish National Fund. They trusted us, and they are supporting us all the time. We need an additional $500,000 to develop our technology to the industrial scale, and of course to start cooperation with the global leaders. So XTPL, global technology, strong, determined team, great market response, clear strategy. Invest in us. Thank you. Questions?
So you're a B2B. So namely your potential customers are the manufacturers of the solar panels and LCDs.
Hopefully everybody heard me. So anyway, I just wanted to clarify, your customers are the manufacturers of the solar panels and the manufacturers of the Samsungs and all of the other Korean and Japanese companies out there that are manufacturing those displays. So what's your strategy for selling to them once you're able to get up to an industrial scale? Or are you just trying to select the few and then get established with them and then work with everybody else?
So basically, our strategy is to first understand that they have invested millions of dollars in their existing manufacturing plants. We want to offer them an add-on to make a step forward with their efficiency, their production costs, whatever. We don't want to make them building new production plants. And then we will start working with early adopters who are most open to taking the risk related to new technology, because we always have technology risk with scaling of the technology. But our plan for the next, I would say, 18 months is to use the money that we get from our investors and make a very big step toward this scaling, so that we can prove reproducibility, process speed, process cost, and most of important is the durability of our technology. So that then it's easier for them to make a real commitment to us.
Question to Sebastian. Why Platinum Seed exited the investment?
They didn't. We did. So we used, because in agreement, we had this very important thing, call option. So we used call option to buy back our shares, because we know for sure they are worth much more now than when we were buying them. So it was
the buyback of the founders, and we strongly believe that what we do is worth taking the financial risk that we make.
How much time and effort do you still need to invest, once you get, of course, the funding, to be ready with the commercial production?
Well, we conservatively estimate that we need 18 months of really extensive development process, and at the same time we plan to do it already in a close dialogue with potential customers. We don't want to wait 18 months before we start talking to them. Actually, we already started our kind of selling strategy by contacting them, showing them here's what we have. They say, okay, show us more, show us this, show us that. So we are going the way they want us to go, because they are at the end the ones who want to pay us, or who we want them to pay us.
Will they prepay, or will you share with them the facility, or will they partner with you on equity?
At this point, the investment that we are gathering will give us independence on making the steps. So none of them, at least for now, invested in us. So the money that we got invested was not from I would say, the industry investments.
Are there any other questions?
Yeah, real quick. You guys want $500,000, and as I remember, maybe I got the numbers wrong, you expect, I think it was around 2020, to have $20 million in sales. What margin do you guys think, guessing you'll work off of when you're at industrial production?
So we have a licensing business model.
Right.
So basically, our revenue is our profit. So
Okay.
the
All right.
cost of our
And that 20
we intend to be an engineering company with many engineers working on other applications field of our technology, tapping the other markets after we make the first step. So we're not producing.
Okay, so you have a licensing arrangement, you have technology that you're licensing. You do this R&D, I guess, for the development in-house and the cost for operating. So you're working on probably 60% margin? Something like that?
That would be a good guess. I mean,
Yeah, something
I-
like that, yeah. Okay.
More than 50%, I
And the
think.
20 million you say is sort of yearly at a similar growth rate that you were talking about, yeah? So probably 20%? What's your growth rate?
Growth rate would be.
I
would
mean,
be
I'm
higher
talking
than-
top line growth rate revenue as you look at it now. You know, what I'm trying to come up with is, what is gonna be at least at this level, an ROI for any potential investment? What can they expect to make in 5 years? Like what kind of return? 5 times money, 10 times money, 2 times money?
Yeah, we want that to be more than 10 times money.
Mhm.
We believe that if the technology is successfully scaled,
Yeah.
this is the risk. If you buy it and we are successful, then the numbers we show are just conservative, because the markets we are tapping are billion-dollar markets. So
Sure,
the millions that we
sure.
show is like, I mean,
Okay, all right, thanks.
Okay, very
If I can just ask real quickly, so let's say you're working with a solar panel manufacturer, what's the level of investment that they have to make in order to incorporate your technology? So they take a license from you and okay, they say, okay, we're gonna go and let's start manufacturing with your methodology. So what's the level of investment that they have to undertake?
So one production line costs about $20 million, and they would need to change one of the toys that they have in the production line, and it would be $2 million plus the license fee that they will pay us here.
Okay, thank you very much, guys.
Thank you very much.